Okay. For many hours, you have been watching the videos, so we talked a lot. Now, by using the agenda video, I will summarize what we talked so far. Basically, it was a long journey for many hours. As I said, you watched lots of videos, right? So we started with what is the quality of service, with the very basics things like, quality of service was managing the fairness, and we will prioritize some traffic, and we will punish others, etc. In case of congestion, what will happen, and so on and so forth. We discussed there. Different quality of service approaches we discussed. INTSERV, so integrated services as a hard quality of service we said, and differentiated services as a second approach, and soft quality of service. So the basic criteria was the bandwidth sharing, and lots of other things was related with the DivServ in this course after that moment. Quality of service toolset we introduced. So because first we needed to understand type of service byte and traffic class byte in the IPv4 and IPv6 headers respectively. So type of service and traffic class of 8 bits, and we seen that 3 bits of it for the IP precedence for the early networks, and then later on 6 bits was giving more granularity, and 64 different options was giving us for the classification and marking, and so on and so forth. Then we understood that IETF define 4 different PHPs, per hop behavior, basically the marking values on the packet. So then we can treat on each and every hop something we can do for that, some actions we could take. So that action could be drop, that action could be queuing, that action could be specific scheduling, and so on and so forth. So we discussed those different PHPs as best effort, class selector for the backward compatibility with the IP precedence. If some devices don't understand the DHCP, they could use basically the CSP to map one-to-one to the IP precedence, and then assure forwarding and expedite forwarding. We discussed all of them basically. And classification and marking we discussed as a quality of service toolset, because first we need to categorize, we need to classify the packets, and then we need to mark, put some values on top of that, and then on the subsequent nodes on the path, we don't have to reclassify again, remark again. Classification and marking is the resource intensive task. That's why we said later on in the quality of service best practices, we should do those operations, especially classification, marking, policing as well, in the as close as possible to the source we said, because BAM resource intensive task. So classification, which is categorization, we need to put in the DivServ architecture, in the quality of service architecture that we use today, we need to put the application that requires same behavior into the same traffic class. And in the RFC 4594 we discussed 12 different type of traffic class, application class, and then based on the application class there was delay, jitter, and packet loss requirements. So some of them is more tolerant, some of them less tolerant, and based on that, some of them TCP based, UDP based, and based on that we treated them differently. Then we seen queuing tools. We talked about them very heavily. Actually, it was the longest part with the congestion avoidance. Also, it was very long as well. So queuing and different queuing mechanisms, some legacy ones like CQ, custom queuing, priority queuing, and WFQ we talked. And then more modern ones as well we discussed, like class-based weighted queuing and low latency queuing. And we said that low latency queuing is the strict priority queue plus CBWFQ, and we explain in each and every detail. Actually, strict priority queue has to be policed and why, and those kind of things. TCP starvation was important there. FIFO is basically even those individual queues in the LLQ, strict priority queue, or CBWFQ, single queue. Inside the single queue we still have the FIFO, and we said that if there is no congestion on the physical interface, then all the traffic anyway goes in the FIFO manner, first in first out manner. Then we started the congestion avoidance. Congestion avoidance was very long as well, and before, normally congestion avoidance you will see in many courses just maybe red, double red, and tail drop. But for us to understand those, the behavior and how how red would help for the TCP global synchronization, etc., we need to first understand TCP and UDP reaction to the packet loss. When there is a congestion, and because of congestion or any other reason, packet loss or ACK, receiver doesn't receive the egg, then how TCP and how UDP react? We needed to understand that, and we talked extensively. And slow start and congestion avoidance phases. Usually people confuse them, and we explain. And with the diagrams, it was very obvious. Tail drop, global synchronization, soft hit effect, and TCP starvation was explained in the video. Remember, TCP starvation. If we put the TCP and UDP in the same queue, TCP will starve when there is a congestion because it will reduce the congestion window. And then it will, of course, exponentially grow with the TCP slow start. And when the traffic comes to the congestion windows, comes to the slow start threshold value, then congestion avoidance will kick in and linear growth, not exponential growth this time, but linear growth was happening, right? We discussed those things, right? And tail drop was happening when the queue was 100% congestion. That's why we needed to use red or WRED to early drop, randomly early drop. And WRED was the Cisco adaptation. So it was giving IP precedence DHCP value to make some packets more important than others. So those more important packets, if the queues also gets full, not just physical interface, not the hardware queues, but software queues also gets full, then some packets will be earlier dropped than others. So then we are prioritizing even inside the queues, tail of the queues, guys. So, and then we discussed RFC 4594 with the chart. We analyzed it, right? We looked at, okay, what would be the application type, and what is the application class first, and then what's the PHP value, what should be the queuing and admission control, whether we should deploy or not. We look at those. We did 12 of those classes, if you remember. There was voice, there was multiple video, there was multiple data and network control, call signaling, management, sorry, scavenger, and many things. Yes, really, when I'm getting excited to teach, I just want to talk and talk. It was very long. It was a lot of, I think, knowledge in this. I wouldn't say long, but fairly good coverage course, let's say. Design models we talk, 4 class, 8 class, and 12 class. We did the trade-off there that with 4 class, we have less configuration complexity, but less granularity also. With the 12 class, maybe complex, maybe troubleshooting point of view, management point of view is more complex, but it gives you more granularity because you just don't say transactional data. You say bulk data, transactional data, best effort data, and so on and so forth. You go to the video traffic, you don't just say interactive video. You can say multimedia conferencing, multimedia or streaming video, interactive video, and so on and so forth. Lots of different video types as well we discussed. So per class, then you can have different policies, queuing policy, scheduling policy, and so on and so forth. That's why 12 class model may be good. It gives you, of course, more hustle, more configuration management complexity. Troubleshooting and everything will be harder maybe, but more granular definitely. Then we started to discuss MPLS diff-serve tunneling models. So basically, when the DHCP packet comes to the MPLS networks, we want to keep maybe the DHCP end-to-end. So it was possible with the short pipe and pipe as we seen. And or we want to change if MPLS EXP bits is changing for any reason, we want to change and copy this change information to the DHCP with the uniform mode. With the example topologies I explained, I think it was also very obvious, and we did some pros and cons. We said that also trade-off there. We talked about them. Then last part, we started the diff-serve MPLS TE approach. So what was that? Traffic engineering. In classical traffic engineering, we said that it is just looking the global pool. What does it mean? If it is not taking the voice LSP, data LSP, video LSP, etc. into consideration, because there is only single LSP which can carry all the traffic. Right? So, but what we did is we said we merged basically quality of service, diff-serve quality of service, differentiated quality of service with the MPLS traffic engineering. So then anymore we were able to signal voice LSP or best effort traffic or the EF traffic, etc., AF traffic, EF traffic on different LSP, and those different LSPs was requiring the bandwidth constraint and CSPF. Constraint-based SPF is basically looking based on class type, we said, and 8 of those class type, we talked about them, and different bandwidth allocation model we talked. Russian DAL and maximum allocation model we discussed, and we've seen that with the maximum allocation there is no CT sharing, class type sharing. So voice LSP's bandwidth is for voice LSP, not for you. So there is no sharing. Even if there is an available capacity on the path, on the link, it is not giving to other LSPs. Basically, there is no sharing one-to-one. So Russian DAL, though, we have the class type sharing, so which means the voice LSP and data LSP can use, if you define them in a group, let's say we call it BC bandwidth, then they can share the bandwidth with each other, and on the path, if there is available capacity, it is using. But priority is what was important there. We talked about them, and then we even although maybe here 1-2 lines, we had 3-4 videos there. We also compare them in another separate video, Russian DAL and maximum allocation. Like in other actually also maybe topics here, you see maybe one video but multiple one only sentence but multiple videos maybe we recorded for that to make it hopefully clear. And I also with this video I wanted to summarize what so far we talked, and you are seeing maybe in the future you might be seeing much more concept, much more topics also I might be adding here. Okay, so far hopefully it was very useful for you, and if you liked it, if you can also share your thoughts in our study group, also of course on the social media as well. Thank you for watching.